So we are actually broadcasting live right now, and I think folks are starting to view us. Let's see. We're still 1 minute away, and I know that there will always be a few stragglers, so we'll probably start this in a little bit. So I think what I'll do is I will give a very brief intro, but not the formal intro for Jess. And then in the meantime, we're going to just talk about how I know Jess and the Princeton Quant Trading Conference. And maybe why don't you say a little bit about Quantopian? We'll banter a little bit for the next 5 minutes. And then we'll get this show started officially at 5:35.
Sounds great.
So as everyone knows, Jess is the VP of Quant Strategy at Quantopian, a fintech startup based in Boston. It's a really innovative platform for doing basically data science and trading strategies online in the cloud. And I'm actually going to let Jess say a little bit more about what Quantopian is about and maybe how you got started in Quantopian and your journey.
For sure, yeah. I'll start with just sort of my quick high-level background. So my background was in basic science. I did my PhD at UC Berkeley, originally studying biophysics, but I was in sort of an interdisciplinary program where I worked in eventually a computational neuroscience lab. So that's where I learned sort of data analytics, and you'll see as this presentation goes on that I'm not a computer scientist, but I learned how to use a computer to do analysis, and so really went from that to my first quant job in San Francisco, a company called StarMine, which hired a bunch of research scientists to build equity stock selection models. So models that would analyze individual stock data and then map that into predictive signals. We weren't a buy-side firm, we weren't a quant trading shop, but we were a data analysis platform for portfolio managers, both discretionary and quant, who would then consume the output of those models either in sort of a dashboard form. If they cared about sort of one stock at a time, we would publish a bunch of scores about stocks. Or if they were a quant, they would take a feed of every score for every stock every day, which always seemed cooler and more elegant to me. And so I worked at that company. It got bought by a much bigger company called Reuters, which then merged with another big company called Thomson Financial. So I ended up going from working at 130-person startup 1 month to a 40,000-person global data and news provider. Effectively the next month. That was an interesting transition to sort of see and go through. And what that meant was that I got to open up a lot the scope of what data sets we could look at as a research team there. So then I spent a couple years staying in the research side, moved a little bit to product and client facing. So the clients I worked a lot with were quantitative asset managers, hedge funds, groups at banks as well around the world. And I got to travel and meet a ton of quants. And that was a really eye-opening experience to see, there were on one hand, many, many different ways to skin that cat of sort of trying to build models that predict the market. But on the other hand, there were a lot of noticeable commonalities. And I started to think more commonalities than a lot of these folks were necessarily wanted to admit, which I thought was interesting. And then when I met Foss and he was starting Quantopian about 3 years ago, they were 8 or 9 employees at that point. What I realized was this is kind of what I had been seeing, was that there was this vacuum out there for a standardized platform for this type of data science and data analysis that was the underpinning for quantitative investing. And everybody was in their little silo sort of trying to convince themselves that they had an edge in an area that frankly was commoditized and could benefit from standardization of the software, so that everybody could kind of compare their results, keep their secret sauce secret. And that's what I saw that made me really excited about Quantopian was, they were all the things that the platforms I had been working with weren't. So open source, typical current programming languages, as opposed to some proprietary version of SQL that someone created 15 years ago, and you are still trying to like convince somebody to upgrade, some specific recipe that God forbid might break something 18 layers down, was on the internet, was extensible, all that stuff. I was like, oh my gosh, wait, and then how much will we charge for this? And Foss was like, nothing, it'll be free. And I was like, this is insane. So that has been a really exciting ride, is to see like, sure, it doesn't start out as like that full institutional platform with everything and all the data and all the markets, but I could see that trajectory. And now I've been here for about 3 years and really gotten to see the team build out, what I would say I think is pretty much, the best platform that I've seen for doing this kind of work, between, that it's robust, it's up, it's on the internet, you don't have to download anything, you can just run with it. It has data plugged into it. And now what's really super exciting this year is, what I do here at Quantopian is actually try to like build meta models that analyze and look at the trading models people in the community build, and try to find ones that are actually work and are generalizable to new data, predictive of returns, positive expected value. And then we're building an investing product based on the back of that, that pays the folks that write these algos returns for their algorithm. So that's been a fun ride so far, and I'm really excited to see where we take it in 2017.
No, that's really great. And one of the themes you touched on was your transition to Quantopian. But I'd love to hear about your transition out of your PhD into industry. I mean, one of the themes at the Data Incubator is helping students make that transition from academia into industry. We run a fellowship that for PhDs and master's students, helping them, move, take the skills that they've learned in their STEM PhDs, and then through the fellowship, getting hired as data scientists in industry. And I just love, and this is a question that obviously is reflective of my background as a PhD who then said, this is, academia is not for me. But I'd love to hear more about your journey, and yeah.
I will time box my answer because I could talk about this like forever. So I went into grad school, not with the intention of having an academic career, but I think, or I'll speak from my own personal experience, to get all the way through and finish, I think you have to drink the Kool-Aid at some point, and what you have to put yourself through to sort of convince your advisor and your quals committee and everybody that you're serious is like you have to kind of go all in. So when I finished my PhD in 2007, I was like, man, I've come this far. Like maybe I should do a postdoc. Maybe I should try to get a faculty job, even though like I never really thought I wanted that. Like here I am. I've gotten over this activation energy barrier. Like now, I might as well. And so I did a postdoc at UCSF that. I lasted about 9 months, but I would say 3 months in, I was like, no, I was right in the first place. This isn't really what I want to do. And that's nothing against like academia, just wasn't a fit for like the cycle and like kind of what I was most interested in working on. And I started to look like to the left and right and say, okay, well, I must have done something useful in this, and I hope to convince myself I've done something useful in these years. And what I felt like was that I knew that I really liked working on data analysis problems once somebody else had gone through like the blood, sweat, and tears of collecting the data set, which I found to be like really tedious and very like attention to detail. And I didn't trust my attention to detail when I would be like, collecting all this data. It just seemed like really a hassle. And I was like looking over at the financial market space and saying like, wow, now, of course, this turns out later to be wrong, but it looked to me like, oh, wow, that's so easy because they just have like all this data and you just buy it, right? Like the markets just like spew out data and you don't have to like carefully collect it. You just like get it for free. And so that was like a thing I thought that seemed really cool about that field. And then you look a little bit into it and there's a lot of, good mentors or examples, sort of people who've taken that path that you can imagine yourself following along. And then that was what worked for me was I just started looking for quantity jobs in the Bay Area. And I just kind of got lucky that I found this group where all the folks they were hiring were, it was like 3 computational chemistry PhDs were in that group. And, a lot of folks that already look kind of like me. And I went to 1 or 2 of their kind of like research meetings and I was like, oh, this is really similar to the way that I thought a lot about like solving problems. So I'm going to get, it felt to me like I'm going to get the upside of getting to continue to do interesting and creative work that asks questions. But it felt like, to me, it was getting rid of some of the aspects that I didn't like as much about the academic track. And I have not looked back, and I was very happy with that transition. I guess one thing I do think, like looking at other folks that I would have sort of been peers that were considering making that move from academia out to different jobs, and then I've continued to talk to a lot of folks. Sometimes I think what can happen when you drink that Kool-Aid in grad school is you actually like don't even place enough value on like how rarefied the skill set that you've acquired is and how valuable it is. And so I will continue to be shocked when people will tell me like, yeah, I'm finishing my PhD in, computational chemistry or applied math or whatever, some like super hardcore quantitative field. And they're like, but I don't think I'll be qualified, to do any jobs. And I'm like, what? You're smarter than like 99.99% of people out there. And you've proven that you'll drag yourself over broken glass to like get to a result and achieve something. Like, yes, you are good enough. People, funny, I think academia really like teaches you humility, which is very good, because you're always like totally presenting your work and having people tear it apart. And I think that's really good. But then on the other side, you can take that too far and not realize like, oh, I have like a really valuable skill set, as long as I have the confidence to like put myself out there.
Yeah, no, absolutely. I love your answer. I think it certainly harmonizes with many things that I've come to think about academia as well. But now, maybe without further ado, we will get the show on the road. So I will formally introduce Jess. And before I do that, I would just encourage folks to ask questions on the YouTube Hangout system. I think there's a little chat box on the right where you can pose questions as you get them. For the sake of sort of getting through data science in 30 minutes, we're going to hold all the questions at the end, but then I'll sort of ask Jess a few of the questions you might have about her presentation, or you can ask her questions about Quantopian, or you can ask me questions about the data incubator. So Jess, Dr. Jess, is the VP of Quant Strategy at Quantopian, a fintech startup based in Boston. She has a PhD in biophysics from UC Berkeley, and she actually began her career at StarMine, which is based in San Francisco, before moving on to Reuters, Thomson Reuters, and then ultimately becoming the Director of Quant Strategy at Quantopian. So Jess runs the research team of analysts and data scientists there, tasked with identifying promising trading strategies built by Quantopian's online community of over 90,000 members and 180 countries around the world. So without further ado, Jess, why don't you take it from here?
Great, thank you for the introduction, Michael. So I think with that introduction, I'm gonna dive in and I'm gonna try to share my screen here. And I think that folks probably already know to go to your GitHub repo. And so there's two things that I put in there for today. I dropped in a slide deck, which we will not belabor. I may kind of use it to sort of set up the discussion. And then there's also a notebook in there. So I should say that while the code, you can just download that notebook and go through and look at the code. If you want to actually be able to run the notebook, it relies on data that it pulls from the Quantopian platform. So you actually need to go to the Quantopian research platform and upload that notebook there. And it may prompt you to create an account, I'm not sure. Or the other option is, I just jumped to my last slide here. This notebook was shared by my colleague, Thomas Vicky, who works with me in our forum. So you can also click this link and I'll hop over and show you that and go to this post on machine learning. And from there, you'll be able to just clone that notebook directly. So let me see if this will show you how to do that. So here I am at quantopian.com/post/machine learning on Quantopian. There's actually two versions of the notebook in here. I think you can go ahead and clone this first one. There's a whole long thread here where there are a couple of improved versions, but they're pretty minimal improvements. So you can go ahead and just click clone notebook from here, and that will clone it into your own research repository on the Quantopian platform, where you'll be able to execute the cells and kind of follow along with me. And if there are other questions on that, you can share them or ask them in this format, and they'll be shared through with me, so I'll try to answer them. So let me just, for kind of context, hop back over to this slide deck. So when Michael asked me to talk about data science in 30 minutes, I also thought, well, I'm not actually a data scientist, and 30 minutes sounds like a really short amount of time. So what could I talk about? But really what I thought was, actually, there's a pretty cool workflow that we have been sort of trying to build out and support on the Quantopian platform. And I could talk about that. And there's a piece that I think does lend itself pretty well to sort of a non-domain expert data science. So here's this nice visual that we built to think about what we're calling the quant equity workflow. And so really everything, like in a lot of analyses, starts, up here at the top of this diagram with data. So in the financial markets, that's anything from market data about, stocks and their prices, to very esoteric data sets like a satellite image of how many cars are in the parking lot of, Walmarts and different zip codes. So that can be a really interesting area. I'm mostly going to think about an area that focuses on like market data and also maybe fundamental data, which is like financial statement data that all companies make available. The second step really is deciding what you're going to define as your tradable universe. So there are a lot of different approaches to algorithmic trading. The one that we sort of have focused on in my research team at Quantopian, while we're sort of trying to identify strategies that we can pull together into a portfolio that we can package into an investment vehicle and offer to investors, we've chosen to go after sort of a market neutral, which means you're both buying stocks and selling stocks short. A market neutral type of product, which exploits, typically small statistical edges in decision making. And so often what you then care about is like having a big universe of lots of possible stocks that you have data on, you could trade. So then you have like a wide range of instruments you can rank and make many small independent guesses or decisions or bets about how stocks will move. And then that's a great setup, right? If you have a small statistical advantage, but you're making, many trades, you're in good shape. So it turns out your universe definition is very important when you do something like that, because you want to basically exclude things that you wouldn't actually be able to trade. The next step with all these little small bubbles that say alpha is, coming up, that's really like a lot of the secret sauce, coming up with factors that predict future returns. And then the next step is what I'm going to talk in this notebook and step through today, which is, okay, let's say that, we either find or are handed a bunch of these, weekly predictive alphas or signals that tell us something about future returns in the market, because it does tend to be true that there's not a lot of these like magical silver bullets out there anymore. The types of signals that you tend to be able to find in the market are indeed weekly predictive. And so today a lot of folks in this field really think that a lot of the innovation is happening at this next alpha combination step, which is you have a lot of weekly predictive signals. Can you combine them together into a way that gets you something really powerful? And then just following this flow chart, but I won't be really discussing today much of the rest of these pieces, but there's a ton about them on Quantopian or elsewhere in the industry if you're interested. Once you have combined your alpha signals into sort of one single alpha, like meta alpha rank on a stock, there's still a lot more work to be done between you and actually trading in the markets. So there's consideration of how to construct your portfolio, taking into account that you might have been thinking of all these stocks as basically interchangeable one for another, but that tends to not be quite true, right? They actually in real life are companies that exist in the real world and belong to different sectors of the market. And so they have different risks that might be associated with them. And then they might have different liquidity in the market. So it may cost you more to get into a trade for one company than another. One company's stock price might be $1 and another company's stock price might be $1,000. So the number of trades you'd place to put on the same size position in two different stocks might be, in one case you would actually need a fractional share, which you couldn't maybe get, and in another case you'd be buying 10,000 shares, and maybe you don't want to do that. So this is sort of the overall diagram, and is something that I think sets the context for this discussion. So now let me hop over. I want to just check and see if people have questions along the way. Can I zoom in? Oh, sorry. Maybe, hopefully I did zoom in. Or is it still too small to see? Let me try. So here's just to, I know this isn't perfect. Oh, okay, zoom in when I get to the IPython notebook. So let me do that. So let me hop over now to this post that I'm talking about, where hopefully you've had time now to come and clone this notebook. And I think I can make this bigger. Let's try. Maybe, maybe not. Can you guys see this okay? Oh, there we go. All right, that's bigger. See if they tell me that you can see that better. Okay. See if that works. Okay, great. All right, so this post that I pointed you to also has a little bit of this context, and actually also has a link. Whoa, it's got even, I think, oh, maybe maybe it's laggy. You guys told me that it was, that there was some like lag to what I would do. So I'm sorry if I'm like resizing this window too much. All right, I apologize if the size of the screen continues to change. Someone had a question, which is what I'm calling factors what is known in machine learning as features? Yes, for the purpose of this discussion, that's the right way to think about it. And I think that comes up in this notebook a little bit further down. So if you go to this post, there's also a link to a blog post that Jonathan Larkin, our CIO, wrote that gives you a bunch of other context. So other resources to go to sort of learn more about that. Recapping here just those distinct stages that I showed you in the schematic. So I skip data here, but defining your universe, finding relevant features, then combining those relevant features, let's say portfolio construction and trading. And the notebook we're going to talk about today focuses on this alpha combination step. So I'm going to just jump over to that notebook because I think we should be able to do that. Okay, so here's the outline of what we're going to step through, and I will go fairly quickly and then leave time for questions so that hopefully we can come back and drill into this. But the intent would just be to give you a little bit of a taste of what's possible. So the first thing we're doing is defining what trading universe to use. Quantopian, we've built a couple of sort of pre-canned universes that you have the benefit of just dropping into your strategy that will select what we think are a liquid, large, tradable 500 or 1500 or however many stocks. I should say our platform works and has data for US equities right now only. So all the stuff that we do is based on that. We'll be bringing online futures sometime in the middle of this year. And then our hope is to include and expand to cover, all markets and all asset classes. But right now we're limited to US equities. So that's what I'll be talking about. So we're going to define the features. We have an API that's called Pipeline, which is the way that we define those features, and I'll show you that. We're going to basically run this data pipeline to pull the right data into our notebook. And then we're going to split our data up into a training and a testing set. We're going to pre-process the data. So we're going to sort of transform the features. We're going to train a machine learning classifier, and then we're going to evaluate the machine learning classifier on that. In the interest of time, and some of these steps are a little bit time intensive, the first thing I'm going to do is just step you through, maybe need to make this one time smaller, step you through without rerunning some of these cells, but I'm going to point out the spots where I think it's interesting to sort of change the parameters that we put in and play around with them. So first, what we're doing is basically importing all of the libraries and data that we're going to need. So some of these things, especially that rely on data sets, are the pieces that depend on the Quantopian platform. So Morningstar is a data vendor that provides our fundamental data on the platform. And then we're going to import a bunch of libraries, TAlib is like a technical analysis library that contains some functions that we're going to use. Down here, AlphaLens and Pyfolio are other open source libraries that my team has created for analyzing factor performance and performance and risk of portfolios that are constructed, stats libraries, and then the sklearn library for doing the sort of example machine learning piece. All right, so the first step is these factors that I've been talking about. And so here, this is just a sample of the types of factors that quants tend to look at. These are examples that you could take and run with, you could modify them, you could swap them out for wholly different values. So when this references Morningstar dot whatever, this is the fundamental data provider that we have on the platform. And then these are the different sort of bits of metadata. One thing I will say about fundamental data is that it's available on a very low frequency basis. So, one thing when I was playing with this notebook ahead of time that I looked at, and I think would be an easy thing to improve, is there's not been any attempt in this example notebook to think about what's the time horizons of these different features or different alphas in here. We're just throwing these all in together, but these fundamental values are available and updated only once per quarter when the company issues its financial statements. Whereas there are some values and factors in here. This is like a moving average crossover signal that's based on just pricing data over 10 days. This is, I think, one of the TAlib factors. So there's a lot of interesting work folks have done that's not captured here at all to say, hey, some of these different factors, really would be expected to predict returns over very different time scales. Potentially, this one might be something that's looking at trailing 5-day volume data. So that might be predictive over a pretty short time scale in the future, whereas some of these other things like operating cash flow to assets, that number is only going to be updated about each company once a quarter. So if it's predictive, it's probably over a much longer time scale. But nonetheless, here are, I'm going to keep skimming past a whole bunch of factors that can be created. Here's a little summary of them. Now these factors are all going to have basically one data point per day per company that's in our universe. So what is our universe? Not diving through any of the code for that here, since we're just going to lean on this pre-built universe. But in the notebook, there's a link and you can go click and read a separate post about how we defined this 1,500 stock universe. The thing that is important is that you want your universe that you define and run a back test over to be survivorship bias free. What that means is you don't want to run all of your analysis on companies that are alive today and then go run an analysis or a back test that starts, far in the past. This one we're running is a pretty short look back, but if you were running an analysis on our platform or frankly anywhere where you wanted to look at how a certain trading strategy worked over the last 10 years, but you only used companies that are alive today, that's what's known in our field as survivorship bias, because you're saying, well, hey, if companies are still alive today and they existed, 10 years ago, 9 years ago, 8 years ago, I kind of know that they didn't go out of business. So I'm probably actually going to have a bias towards having a strategy do well that doesn't contain dead companies. So this Quantopian 1500 universe is survivorship bias free and contains companies in that universe that met those requirements as of the date of the back test. All right, so now what is the pipeline of data that we're going to pull in for our analysis? So I'm not going to have time to really dive through how this pipeline works, but suffice it to say we're going to be pulling in the factors that we want for the universe of stocks that we care about. And the other critical piece is we need both the factors that we think are predictive of returns, and then we need the forward returns. So what do I mean by that? Well, if I think that I can take a bunch of these data points that I've called factors or features, and I think that I can use them to predict what stocks I should be buying and selling, then the way to test that is to sort of say, great, okay, if I do that and I buy some stocks long or sell some stocks short, how does that work out in the future? So the right way to do that is to grab returns data, and we're going to be grabbing 5-day forward returns data. And you'll see as we go further down that we're going to have to do a little bit of aligning the data to basically shift and align, effectively like today's factor values with the returns 5 days from now. Okay, so now I'm going to run that. And here where I run this pipeline, this is where I'm defining how much data I want to grab. So in order to have this notebook run in a timely fashion, although I ran it before and it takes, I think, about a minute and a half to pull this data. So I'm not going to do it the first pass through. It's just a pretty short sample of data, but you can open this up and run it over longer time periods. So here we're going to say, great, give me data from March of 2016 through September of 2016, and then show me what that looks like. So here's a table showing you what data we've pulled. So on each given date, you can see the securities. There is both a sort of ticker symbol, which is something you might recognize, like Apple. And then there's also what we call a security identifier, which is our internal identifier for that security, which is unique through time, whereas historically tickers aren't guaranteed to be unique. So keeping track of like what security is what over time through things like symbol changes, mergers, and acquisitions is actually a huge headache in this field. So you'll often see these types of systems where you've got both a unique identifier through time and then a reference to like a current as of that date symbol. So we can know and hope, especially it's recent data, be sure that, oh yeah, this is the Apple we know and love, and that's that company as of March 7th, 2016, and then we can read across. And these are the ranked values for all of these different factors or features that we've chosen to look at for Apple. So that's what we've got, is a big table full of data that's aligned against a particular day and then across the universe of securities that we wanted to look at. So there's the other end of that table. You'll see there are missing values, which at this stage of our notebook show up as nans. I think further on, we have to pick what we want to do to sort of handle those nans. I will say as a sidebar that handling missing and incomplete or erroneous data is, one of the least glamorous but most important parts of this type of workflow. So we've done some simple things in here, but actually usually figuring out how to handle real world data, like as a contrary to what I was saying in our little pre-discussion about, this is one of the places where, like, when I got into this field, I thought, oh great, all the data is like clean and super easy to work with. And this is a great example of when, I realized, oh yeah, that's not true. Especially interesting data sets tend to have lots of not clean and missing data, and figuring out how to handle them is important. All right, so there's nice text in this notebook that hopefully can kind of walk you through it. But here at this point, we're saying, okay, great. So now we've ranked these factor values on each day for each stock. I don't have time to run through and really talk all about why ranking is so cool, but these are valid points. Basically, when you go from a raw value to a ranked value, you increase your robustness to outliers, and you care about something that's a little more conservative, which is just relative ordering among a set of stocks rather than absolute values. And you also get the benefit of having a bit of normalization across many different types of data so that you can, combine them together in a way that hopefully increases their power. All right, so now is where we're going to go through, and I'll skim over it. But remember, I mentioned that we're going to need to sort of shift things around so that we line up today's factor ranks with the forward returns, and we're doing that again because we want to look and say, does today's factor value predict the returns I'm going to see 5 days from now? That's a big ask, right? To the extent that you have anything that's beyond chance, you have something that has the potential to be a profitable trading strategy. Here we're sort of simplifying this into saying what we're going to care about 5 days from now is whether we can correctly sort stocks into sort of top 30 percentile winners, bottom 30 percentile losers, and in the middle, we don't care. That's a big generalization. Really, you would, if you wanted to take a strategy like this and bring it all the way to something you trade, you're trying to do more than just sort of bin completely into like up and down, but you want to get like a nice, really more granular relative ranking. But this is a good sort of working example. So here's where we're shifting and masking that data to make our table line up nicely. And then now here's where we're going to split our data into training and testing. And so we're going to take 80% of our data and use it to train on, and we're going to save 20% to test on. This is a simple example, and I mentioned that we took a small amount of data, so we sort of expect this to be a good working example and a good kind of first step, but not a substantive enough amount of data that we'd think we'll be able to get results that we would really draw that much of a conclusion from. Nonetheless, you get sort of that idea. So now we're going to train the machine learning pipeline. I will say, like I said, I'm not a computer scientist. I'm also not an ML expert. But Thomas Vicky, who works on my team, who's based in Germany, does do a ton of machine learning stuff. And he was excited about this ADA boost classifier. But really, you could pick, any one of many. And I know it's a fast evolving field of different ways of looking at weak classifiers or decision trees. And this example of the idea is, I think, really kind of well suited for this problem where, you'd like to know in the future how to classify, like you'd like to know today how to classify stocks that in the future are sort of winners and losers. And so, intuitively, I think this model kind of makes sense. So here is where we're training the classifier. This will run and give you a time. So this step is actually like reasonably fast. And then there's basically an accuracy score that we're spitting out. So here on this model with this set of factors, we get better than chance accuracy on our training set, not, anything crazy looking. But of course, the real question is, well, cool, but you held that 20% of data out. So, how good are you going to be on that? So the next step in here is evaluating how that classifier does on the data it hasn't seen. And if you've done any work in this kind of field at all, you'll know, okay, well, that's really like a lot. That's where the rubber meets the road. And it's, very difficult to get models that really generalize to new data. And so that's kind of where a lot of the value is created. So for this one, sadly, but kind of how we expected, it doesn't look like it does better than chance. So it isn't better than chance over these timescales, but what can we learn from this? So one of the things we like to look at, and we're doing some work with this on sort of a different question internally, is, okay, and I can't make this look smaller, but I think it will suddenly look smaller once I stop talking. So you can then say, what are the relative importances of these different features? So let's say that we did get this model to being something that looked predictive, and we liked it. The nice thing about this method is that it's going to also tell us these feature importances. So we could go back and say, hey, this money flow volume 5-day, isn't really very important, and maybe it's adding complexity and not value, and you could get something out of that. So this is the whole notebook that I wanted to run through, and there are two more follow-on companion posts to this that you'd be able to find on the forums, where Thomas has sort of taken this analysis a little bit further. And then also in this notebook, there's a bunch of cool links to additional resources that you could go to, other machine learning resources, and then ideas about how you could turn this type of thing into an algorithm, not just a notebook. So let me stop there. I'm going to scroll back up to the beginning of this notebook and see if there are questions.
Cool. Thanks so much for that, Jess. It's really great talk. And I know that Quantopian has a lot of tools for helping people who want to do back testing and the whole 9 yards of doing quantitative trading strategies. And the tools that you guys provide really help people facilitate that. So I have one question here from Jacob. So Jessica, was doing your PhD worth it, or would you have been happier skipping those years and learning the data analysis skills on your own?
Great question. I personally think for me, it was worth it. I wouldn't go back and not do it, because I think that while I didn't stay in the exact same field, and I would love to think that in hindsight I could learn and sort of get to the same place faster, I feel like it's really, well, it's hard to guess if you could have learned a whole body of stuff faster. Like in hindsight, maybe, but for me, I don't think I would have had the discipline to just focus like so purely on like the analysis and like formulating questions. And I think for first kind of like training and learning, being in like a environment with, you know, a whole bunch of other super smart people that are also focused on research questions, like I got a lot out of that. And while I was doing it, I enjoyed it. I mean, I remember thinking going into doing my PhD, I had taught high school like AP chemistry and physics for a year. And I remember thinking like, this is really hard. And I could go to grad school next year and I would make the same amount of money and I would be the student. So at that time, it didn't seem like a huge opportunity cost. I like couldn't believe that you could get paid to go to grad school. So it didn't seem bad at the time, you know, as an idea. I would do it again.
Absolutely. And so another question we got, do you think that a PhD is necessary for becoming a data scientist or a quant?
No, I don't think so. And I think, you know, today and this sort of field of data science has really, I think, look, computer science changed that, I think, and showed that it's possible to get that same level of expertise like purely by going and working at a company. Computer science is really applied, so I think it does depend like where you want to go. So I don't think you need to have a graduate degree to get a good job in quant or data science. I think there is still, but hopefully it's on its way out, like a little bit of snobbery around certain categories of jobs where as shorthand, people will sort of say, well, this I think is going to be like a PhD level research position. I think that's kind of like going by the wayside, but it's not completely gone. So I think it just, you know, I certainly wouldn't advise someone to go get a PhD like as a checkbox for getting the job that they want. I think, you know, you should do it if there's something you just like want to spend 5 years really focusing on and learning, you know, kind of that way. And then I do think once you have a PhD, it can open a lot of doors, but it's not like you know, I don't think it's worth it to sort of tick that box to get a certain job. Then I think you would just try to get a job that's a better first step to that job, you know, or maybe get a master's, or, you know, I think today, I mean, actually, you know, like your program at Data Incubator is a great example of, you know, today, I think people can be a lot more tactical with, you know, getting education, you know, in data science, either to supplement, you know, a degree or something like that. I think there's a lot more options out there today than there were, you know, 10 years ago.
Yeah, I mean, absolutely. And I think I agree with that as well. When I think of sort of things I learned in my PhD versus sort of things that I use now, there's certainly some overlap, but there's also a reasonable amount of things that don't overlap. And one of the nice things about, you know, the modern ecosystem is that you have so many tools available on so many resources available on the internet, and all these tools are free. And you have all these programs, for example, the Data Incubator, where you can sort of come and learn about data science. And I think that really has opened up a whole many avenues for people in their careers as they want to transition into this kind of analytics, quant, data science field, whatever you want to call it. All right, so in the interest of time, I'm just going to call 2 more questions. I guess the first one was directed to me, but I'd actually love to hear your thoughts about it, Jess. What traits, skills do you see from data scientists that become CMOs, CTOs, and other chief X roles? I guess they're trying to think about how they can support their growth mindset while being a data analyst and marketing strategist.
I'm curious to hear your answer. I think what I would say off the top of my head is, I think one thing that comes with, you can just come with it or you can learn it, is really being able to take a step back and think about the broader context of like the problem or the question. So I'm not saying that I'm always great at this, but I try to think about it. I think it's really easy when you're super smart and technical to get sort of stuck inside of like the weeds or the implementation details of a question. And sometimes it's like you get a ton more value out of being like, hey, wait a second, like, well, how do we even get here? And why am I even looking at this question? And is this even relevant? And is this like number 1 priority out of the 82 other things I could be doing? So like having like not like knowing when to put the blinders on to get really deep to get a technical answer, and then knowing like when to take them off, and sort of think about the context and make sure you're working on the right problem, is one thought I have.
Yeah, I mean, I completely agree, right? I think that there's kind of two sides to that, right? Like I often call this latter thing when you sort of take off your blinders, I call it the metagame, right? You want to understand the game you're playing, you want to understand the metagame you're playing. And I've certainly found that as I moved sort of higher and higher in my career, I began sort of using that skill a lot more.
Yep.
And I think it's an interesting thing, right? So it's not just that you could get to that role by completely understanding how to think about, well, what is the most important problem to solve? Because like the average MBA has that. It's really sort of marrying that ability.
I like that subtle dig at the average MBA. I totally support that.
I can't help it. My wife's an MBA. I have to constantly do this. But so when you have these sort of different, when you have the skills, that kind of more generalist skill set, it's important to marry that with the sort of deep technical understanding. Because a lot of what you're trying to do is say, okay, so these are the 4 problems, but I know this one's very hard to do technically. That one's actually kind of easy to do. And even though it's maybe only priority number 2, we can knock that out in an afternoon. So let's do it.
I think that's the superpower. And it's like, if you have the technical chops yourself to be able to sort of prioritize and identify the low hanging fruit, and you have that meta problem in your sights, that's a very deadly combination. And I think it is, even though I always say like, there's so many smart people out there, like you can always find somebody smarter than you, which I'm reminded of that on a daily basis here. I do think that it's very valuable and not as common to really have that, both of those skill sets in the same person is very powerful.
Yeah, completely agree. And then the last question, this is from @Sloth. How useful is it for one to learn TensorFlow? Obviously, there's a lot of interest in deep learning now. And I guess sort of I noticed this too, when you're doing your analysis on Quantopian, you were just using scikit-learn, the sort of the more kind of well-established, well-trodden machine learning path within Python. So what are your thoughts there?
I'm not the best person to answer that, except what I would say, because again, my background is like really on the formulating the question, and then I'm always interested to like work with really smart people. Like, so this guy Thomas, who works on my team, is an amazing data scientist. And what I think is cool is just sort of try to look and say, all right, so if there's a new technique, library, approach, something available, and that's, there's sort of 2 sides I think of. One is, it's fine to go try a new shiny tool and like see, oh, is this going to have some benefit for my problem? It may not. So I think, when you have to be tactical and you're trying to like achieve a certain result, you have to say, like, is that tool something I'm going to spend time investing, learning if I can use it? Because there's going to be ramp up time. And then like, you got to time box that and be like, well, okay, I'm going to spend, some amount of time figuring out like if that new shiny tool is good for my problem. And if it is right now, cool, hop on it, be there first. There's often a big advantage in that. But also like, if it isn't, then, I think you do sometimes see folks, especially that come out of academia, or frankly, I'm gonna say computer scientists too fall prey to this a lot, which is there's always like a next cool cutting edge tool. And so you'll see people being, like actually Thomas, who I work with, was even saying this, we built this whole pipeline for evaluating algorithms, and he used like one certain type of like data pipeline tool, which I think is called Luigi. And we have to like do a little bit of work to like finish that up. And he's like, oh yeah, I was looking at that and like, we're close to finishing it, but there's like a newer thing that's cooler than Luigi. So like, I'm kind of tempted to go just rip it all apart and like with this new thing so I can learn it. But he's like, but you know what? I've already told myself like, that's not right. I should finish this because then we'll have it. We can use it. And then I can test that new tool. So I don't know if TensorFlow is an example like that, but I think it depends on your personal like job function and use case. And like, I would put it in your science experiment earmarked time to figure out like if it's valuable for you to learn it and use it.
Yeah, absolutely. We used Luigi at Foursquare, and I remember there was this one day when we had to migrate from Luigi from a previous technology called Uzi. There's just like, yeah, I mean, welcome to the tech world. It's just like buzzword palooza.
Yeah, exactly.
But yeah, and it was just I mean, it was a major effort. And yeah, like, as you said, at the end of that, everyone sort of scratched their head and said, well, 3 months of work later, should we migrate again? And you can always go down that rabbit hole. And it's always difficult to know, it's a bet every time, much like stock trading. But yeah, so we're actually just finishing up. So I will make a brief plug for the Data Incubator. So we're accepting applications, and they're due next week. This is for our free data science fellowship in New York, SF, DC, Boston, and Seattle. So please go to thedataincubator.com if you want to sign up and apply for this free fellowship. And Jess, if they want to learn more about Quantopian or start using the platform, what would they do?
Yeah, hopefully you can find some of those reference links that I put in the slide deck, or just go to the platform. If you were specifically interested in these machine learning examples we were talking about, there's like a little search bar in the forums, and so just type in machine learning and you should get a whole bunch of posts. And then also feel free to email feedback at Quantopian or me directly if you have questions about the platform or anything else.
Great, wonderful. Thanks so much for joining us, Jess.
Thank you for having me. This was a blast.
Take care.